Okay, welcome back to the clamped knurling tool body. This will be the last segment on this part. We should be able to finish it up here today. All it's left to do is to drill a few holes. We have two groups of 4 counterbored holes in the face to drill. We have a couple of 5/16 18 tapped holes in the edge of the part to lock the knurl holders down, and we have a couple 5/16 where are we here? 5/16 18 tapped holes in the ends to put pressure on the knurls. Okay, so let's start out with these counterbored holes. Seems like as good a place as any. You see these holes are located off the center of the part. They're 1.313 on the x-axis, the first hole, and 0.563 off the y-axis. Okay, and they're symmetric, so 563 up, 563 down. So let's start out. Let's center up on this hole up here and go from there. First thing we need to do is pick up the edge of the part with the center finder. Just move in till it kicks out. And then let's use the dials for this one. I know that center finder is 200 thousandths in diameter, so we'll set our dial for 100 thousandths off from 0. Then when I move into 0, the center of the edge finder will be right on the edge of the part. Okay. All right, now we know that this part is 6 3/4 long, so we want to move into the center of the part, so that'd be half of that, or 3 3/8. So let's move over 3 3/8 inches. There's 1 inch, 1, 2, 3, 4, 5, 2 inches, 1, 2, 3, 4, 5, 3 inches. What did I say? 3 3/8. Okay, 3.2, 3. 75, okay? So that's on the center of the part. So now we can loosen up the dial here and then zero out the dial on 0. So that's the center of our part. Now we need to do the same thing on the y-axis. Okay, right about there. Set our dial 100 thousandths before 0. Okay, you notice on this one we're going the opposite direction. We're going counterclockwise. It doesn't matter which way you go. The end result's the same. Move to 0. Okay, so now we're the center of our spindle is over the edge of the part. Okay. Now the width of the part is 2 3/4, so we need to move half of that, or 1 3/8. So there's 1, 2, 3, 4. There's 1 inch. 5 turns is 1 inch. One more turn is 200, 350, 60, 75. Okay, see, we're counting backwards, but that's fine. Works either way. Now you can go ahead and set your dial on the y-axis to 0. Now we have both dials set up, okay? And I'm going to set my digital readout on 0 at this point too. We'll do the other set of holes using the digital readout. So I switched over to absolute mode. Okay, we're going to call that the center of the part, and I'll show you how to use the incremental mode to drill those 2 4-hole patterns. So now we want to move over to that first hole, 1.313. So let's do that. All right, that's 1.313. Then up 0.9. What did I say? Up 0.563. 5, 563. Okay, now that's the position of our first hole. Okay, these holes are 201 diameter through. Okay, I like to use these screw machine length drills. Okay, they're split point on the end, and they're short, so you don't need to use a center drill with them. It saves a lot of time. Let's go ahead and drill this through. Grab some coolant. All right, there's one hole. All right, now we can move over 5/8 of an inch on X. But if you look at the dial's set on like 113. Okay, so either we can do the math in our head and add 5/8 to that, or you can stop and reset your dial to 0. Okay, that makes it easier to do this hole pattern, but then when you do the other one, you've lost your the center of your part. So if you want to do the math, you can just add 1 5/8 onto this and continue on, or you can reset it and then pick up your center again for the other hole, the other set of holes. All right, so let's do it this way for now. Move over 625 in X, and the same thing for Y. We want to move 1.125 down, 2 times 563, right? So let's go ahead and set this on 0. And move. Okay, now we have to watch our backlash too. Okay, if we move down, we have to go past our end point and come back to it. So we want to end up turning clockwise to get this play out of the screw. So let's move our distance 1.125. 2, 3, 4. There's 1 inch. 1.1. Okay, there's 25 right there. But I got to remember to take the backlash out, so I got to go past it and come back to it. Okay, so stop on 1.125, and when the dial's turning counterclockwise, that removes all the backlash. Okay. I forgot to drill a hole in the last location. Too busy talking and working cameras. So let's just drill this one. All right, now go back up where I was. Put that hole in. Okay. Now where were we? 1.125, then we'll move back to 0 where we started for this last hole here. Right there. Okay, that's the first set of holes. All right, now let's do the other side. And now I've lost, like I said, when I moved the dial, I lost my 0 reference on the part, so I got to pick that up again. So let me go ahead and do that real quick. Actually, what I can do, I already have the digital readout set, so I'll just use that to find center again. So there we are, 0, 0 right in the center of the part. Okay, now I'm going to forget about the dials. Okay, we already did one set of holes with the dials. Let's do this next set of holes with the digital readout. You can see how much easier it is. If you guys ever have some extra cash and want to spend some money on your milling machine, digital readout's probably the best accessory you can get for it. All right, so let's do that same thing. Let's move over 1 5/16. Okay, you can see we're set on 0, 0. Let's move over 1 5/16. We don't have to count any dials or anything. Just move over 1.313. 312 something. You know, it's 5/16 is 1.3125, so that's close enough. That's good. And we'll move up 563 and Y. Okay, 5625, somewhere in there. All right, now we can, we're lined up on our first hole. See that? Okay, now we can switch over to what's called incremental mode and zero out the X and Y axis. Okay, now we have a 0, 0 reference point to work from for these holes, but we can always go back to our absolute position by hitting this absolute button. Okay, so now we can go ahead and drill this hole, and then we can just step around and do the other 3 holes without losing our reference to the center of the part. So let's go ahead and do that. There's one. Now we're going to move over 563. Okay, somewhere right in there. That's for the second part, or the second hole. Now we have to move down that 1 and, what did I say, 1 1/8 in the Y axis. So just crank it down. Don't have to worry about backlash, you know, if we go past, we don't care. We can come right back to 1.125. The digital readout reads the position of the table. It has nothing to do with the lead screw. So all you do is dial in the number. You don't have to worry about backlash. All right, there's a 1.125. Let's go ahead and drill that one. Okay, then back to 0 on the X. Again, we don't care if we go past, you know, we can go each side of it. Fine, doesn't matter which direction you're turning the crank when you stop on 0. It's reading table position. Okay? Okay, so that takes care of the holes. Now we have to put the counterbore in. There's several ways we can do that. One way is just to use a 3/8. Let's see, it is 3/8, right? Yeah, 375. So you can use a 3/8 end mill. just put that in and counterbore the holes to that, or we can use a counterbore like this, a piloted counterbore. Okay, this has a pilot the size of the drilled hole, and then like a counterbore, or almost like an end mill, a guided end mill, to do the cylindrical part of the counterbore. So we can do this. We don't even have to have it in the chuck, but if you want to do it with an end mill, leave it in the chuck and just go around to all those positions and counterbore each of the holes. You don't want to use the chuck for an end mill because it doesn't hold very well. You want to make sure always use a collet for an end mill. Chuck, you generally can't hold an end mill tight enough in a chuck to keep it from walking out. And unfortunately, you don't usually discover that until the thing's already walked out and went too deep on you. So, just as a general rule, don't use a drill chuck to hold an end mill. It'll come back and bite you. Alright, so we just need to run the spindle or the quill down against the stop, and then just raise the table up to scratch the surface with the end mill. Okay, right there. Then we can set our dial to 0 on the table or the Z-axis. Whoops, this is hard to do with one hand. Okay, like that. Now we need to go, what's the depth on that? 190 thousandths deep. So loosen the quill, crank the table up 190 thousandths. Then just go ahead and counterbore each hole. Okay, and then I'm just going to go around using either my dials or my digital readout. Go back to each hole. Whoops, missed that one a little bit. Supposed to be 563. There we go. It's better. Okay, I just realized I made a mistake. Paying too much attention to the camera and not enough attention to the part. Instead of spacing these holes out 5/8, 0.625, I moved over 9/16. Okay, I got the two dimensions mixed up. So these holes are now 0.563 apart instead of 0.625, which isn't going to hurt anything, but we'll just have to allow for that on the mating part, which I think is probably going to be that small flat plate. Okay, just to hold the knurl holder into the slot. Okay, doesn't matter if the holes are a 1/16 different on that. It's going to do the same thing. So let's just go ahead and finish this up and move on to the next set. That takes care of those, and the next ones I'm going to do using the counterbore instead of the end mill. Okay, so let's just take it out, and I'm going to take the burrs off the back side. Knock these burrs off. And as soon as I saw that counterbore not quite centered up on the hole, I knew something was up. I debated on going back and remaking this part real quick, but truth is, it just doesn't matter. So, you guys will do it right. Mine's a little bit off. No big deal. They're both going to work. So let's go back and put the drill chuck back in, and I'll show you how to use this counterbore. Someday I'll get busy and build a power feed for this table. So I don't have to crank the thing up and down all the time. I like to do my counterboring on the top of the vise here. It makes it easy. Okay, all you do is just run your counterbore into one of the holes, set your quill stop, crank the table up to 190 thousandths, same as we did with the end mill. Then go ahead and counterbore. It's a lot easier. You don't have to keep repositioning the part because the counterbore follows the hole. It's the best way to do a counterbored hole by far. Alright. That takes care of those. Yeah, I love aluminum. Gotta love it. There we go. Alright, now let's switch over and do the 2 set screws on the edge of the part here next. So let me back out here so you can see what's going on a little better. Okay, we got to pick up the edges of the part again. Back on center. Yeah, just use the dials because it's so much fun. Okay, we want to move in. To make sure I got the right, working from the right surface here. Okay, actually this, glad I checked that. These tapped holes here are located off, yeah, these parts here are located off the side with the slots on. So in this case that's going to be the back side, not the front side. So let's go ahead and do that. Okay. There's 0, and then we have to move in 310 thousandths. That's 5/16 rounded down. Okay, so 3125 rounded down to 310. Good enough. It's not critical. All right, now we can work from either end. We don't care about that since the part is symmetric. Set my dial on 100, crank to 0. Okay, that's the edge of the part. Now we'll move over half of the length of the part, or 3.375. I lost count. Start over. Alright, there's 0. 1, 2, 3. It's 3 inches, 375 thousandths, okay? This counting business is tough stuff. Alright, now this hole, or these holes have to be spot faced first with our end mill. Because you can't drill a hole to an accurate location on a curved surface, or a sloping surface or slanted surface. So all we do is spot that angled surface with an end mill, give us a nice flat surface to drill on. So these holes are 1 5/8 from center. .625. I cheated. I used the digital readout. Okay. Deal with it. So now all we do is just go down with our end mill until we get a round hole. You can use your stop to kind of sneak up on it. Now, can you see that? Let me move in a little bit. I'm against my stop now, so I just keep bumping the table up a little bit until I get a completely round hole. Okay, we'll move over 1 5/8 the other direction. Do the same thing. Now the stop's already set, so we don't have to mess around with it. Okay, that's the spot face. I think the note on the print is what? Spot face to full diameter? Spot face 0.38 to full diameter. That's what we just did. So now we can put the drill chuck back in. Drill our tap, put our tap drill in, and then tap at 5/16 18. And the tap drill for a 5/16 18, according to my trusty tap drill chart, is, where are we at here? 5/16 18 is a letter F, 257. If you don't have a letter set of drills, you can probably get away with a 1/4 inch, 250. You can have a little deeper thread, okay? But this being aluminum, should be fine. There's one. 1 5/8 back this direction, and put the other one in. So now we need a 5/16 18 tap. Now I'm going to power tap these, okay? So I'm going to put my tap in the drill chuck. I'm not going to tighten this chuck down real tight. You know, I have a video on power tapping. It tells you all the fine details about how to do it. But basically you just let me back out here a little bit. Basically you just put your tap in the chuck, but you don't tighten it down tight. You leave it a little bit loose so it can slip, okay? I just snugged it up a little bit. And I like to use WD-40 as a tapping fluid on aluminum, but I don't see any for the moment, so let's just use some cutting oil. A little oil on it. Slow the spindle down a little bit so it doesn't go nuts when you start screwing it in. Make sure your stop's down far enough so you don't bottom out before you do the tap. Then with your hand on the stop switch, just feed the tap in until it grabs. When it gets down to the right direction or the right depth, reverse it and it'll come back out. There we go. Okay. You saw it slip a few times on the way in, right? That's what keeps the tap from breaking. First time you try that, you're going to want to run it really slow so you have lots of time to think. I've done it about 1,000,000 times. so it just comes second nature. But first time through, you better run it pretty slow till you get the hang of it. Okay, again, make sure it's well lubed. Hand on the reverse switch. When it gets down to the bottom, turn it off, reverse it. Okay? Quick and dirty way to tap a hole. Those are done. Now these holes on the ends are a little tricky because the part's so long. We've got to set it up on end. I think we can probably squeeze it in here. That I'll probably use put a stop on this side, work stop. Let me move over a little bit. Okay, put a stop against this side, and then I'll use a square against the opposite side to square the thing up. So let me get that set up. I got to change the battery in my camera, so I'm going to tune out for a second. Okay, so let's get the work stop set here against the side of the part. If you don't have a work stop on your vise, it's a pretty handy device to have. This one's getting kind of, screws are getting kind of worn out in it. Change them out, but basically it's just a hard stop against the side of your part. Give you some place to stop. And now we want this part nice and vertical, so I'll use a square on the opposite side and just kind of push it against the stop. That squares everything up. Lock it down, we're good to go. And more table cranking. Okay, so now we got to pick up the part again. I always keep this edge finder right on the in the coolant tray on my vise, just so it's handy. So which surface does this dimension from? It is the same side as the other tapped holes, right here. And it's 375 from this surface. And this, I hope this will reach. Looks like it'll reach. This is halfway up, half the diameter, thickness of the part, or the width of the part, which is 1.38, 1 and 3/8. 380. Alright, this is also a 5/16 18. Hole, and now the tap. Nice thing about power tapping is you do the part all in one setup, so there's no you don't have to worry about changing out the part. Just use the same setup you used for drilling the hole. Okay, takes care of that one. flip it around and do the other one. Should be all set. Just have to make sure and use that square. Push it against the work stop so it's lined up properly. And that takes care of that. This part is finished. Almost. One more thing I want to do to it. So let's get the burrs off here. Alright, now the only thing left, if you look on the print, you'll see there are radii called out on this corner, okay, this corner, and these corners. Take that back, just these corners. So these 4 corners, I'm just going to go over the belt sander and throw a quick radius on them. You can't really use a corner rounding end mill on these because they're not 90 degrees, okay? So we'll just use the belt sander and maybe clean them up with a file to make them look pretty. So let's go ahead and do that, and this part will be done. Always make sure your table is square. So I'm going to stop and use a square because this baby is way off. Must have got bumped or something. It's way off. That should do it. That looks better. So the radius called out in the print is, where are we at? There it is. 1/4 inch radius, okay? So I'm going to grab a 1/4 inch radius gauge. So we can get all 4 of these guys the same. Takes a little knack to get a good looking radius on a belt sander. The trick is not to go too far. Don't go all the way over tangent to the surface, okay? Stop a little short like that. You can use this part of the gauge. It's less than 90, so it fits on that surface nice, and it just tells you when you get your 1/4 inch radius or whatever you're shooting for. Again, this is a non-critical part of the body. It's just for looks. So we don't have to take the time to set up like a rotary table or something like that to put it on. It doesn't need to be that precise. It just has to be pretty. So take your time, use a gauge, and it'll look pretty good. Now we can just take you want to make it look really pretty, take a smooth mill file. Make sure it's a clean, smooth mill file. Get all the chips out of it with file card. And you can, this is a way to make a belt sanded radius look really nice. Just start flat and just round it off a little bit. Clean all the sanding marks off of it. Just like that, okay? That looks pretty nice. So that finishes up this part, okay? I think next we'll move on to we'll do a steel part for a change. We'll do the part that mounts on here that you clamp on your tool holder, your tool post. I forget what I called it. I don't have the print in front of me, but you know, that thing. So that's next in line. We'll see you then.